In today's video, we will look at the limits of multivariable functions. Let me say now we have the following limit, which we have to determine if it exists. When you have this particular problem, before you can try to factorize it further, try the direct substitution and see if it works. So when we check, the limit is situated at the origin, 0 and 0. Therefore, when I substitute 0 where there is x and y, I will get 0 plus 0. All this is over 0 minus 0 plus 1, which gives me 0 over 1. And 0 over 1 is just 0. Since these two coordinates, they give me a defined value, it means the limit at this point is defined. At 0 and 0, this limit is defined at this point. Let us take another problem. We will look at the limit xy situated at the origin of x squared plus y squared. All this is over the root of x squared plus y squared plus 9 minus 3. We also want to determine whether the limit exists. The key thing is we first try the direct substitution. If we substitute directly with the origin, we'll have 0 plus 0 over, all this is over the root of 0 plus 0 plus 9 minus 3. And this will give me 0 over 0 plus 0 is just a 0, the root of 9 minus 3. The root of 9 is the same as 3. It means now you have 0 over 3 minus 3. 3 minus 3 is a 0. Then you have 0 over 0. And bear in mind that 0 over 0 is undefined. So if you have a limit of which the direct substitution gives us undefined, we are going to try to solve the problem using a different way. When we check here, we have the square root of x squared plus y squared plus 9 minus 3. It means we are going to multiply this function by the conjugate. So it means we'll have the limit xy 0 and 0 of x squared plus y squared over the square root of x squared plus y squared plus 9 minus 3. Then now we multiply by the conjugate. The conjugate we multiply by this number, hence we change the sign. It becomes positive. It will now be x squared plus y squared plus 9 plus 3. All this is over x squared plus y squared plus 9 plus 3. Then we multiply throughout. It means now we'll have the limit of xy of 0 and 0. This multiply everything this side is the same as when we have x squared plus y squared plus y squared. It multiply everything, x squared plus y squared plus 9 plus 3. All this over. This number will multiply the square root. This number will multiply the square root, and when you multiply this number, since the numbers inside the square root they are the same, then we'll be left with what is inside the square root. which is x squared plus y squared plus 9. And then everything here inside the square root will multiply 3. And then when you multiply 3 by this number, and this number, together with the 2, then when we add them up, they will sum up to 0. Therefore, there's no need for us to waste our time. So as for now, I'll just go straight to 3 multiplied by 3. 3 times positive 3 is the same as minus 9. And then I will have the limit as x, y approaches 0 of x squared plus y squared. Everything inside the square root is x squared plus y squared plus 9 plus 3. 9 minus 9 is the same as just a 0. So on the denominator, we are now left with x squared plus y squared. Then now when we check, x squared plus y squared will cancel x squared plus y squared. Therefore, we are now left with the following limit: xy 0 and 0. Now we have x squared plus y squared plus 9 plus 3. When we're at this point, now we can do the direct substitution and see if we get our answer. Once you start doing the direct substitution, you are no longer going to write the limit. It means now we'll have 0 plus 0 plus 9 plus 3. Hence we have the root of 9. The root of 9 is 3 plus 3. And 3 plus 3 give us a final answer of 6. Therefore, this is the answer that we get. So now let us look at a different problem. Let me say we want to show that a limit does not exist. Show that the following limit does not exist. We have the limit as x and y situated at the origin of xy plus y cube, all this is over x squared plus y squared. We are told that the limit does not exist. So you can also try the direct substitution before you prove that this limit doesn't really exist. So if you do the direct substitution, this is 0 plus 0 over 0 plus 0, which is 0 over 0. And 0 over 0 is undefined. Then now we want to prove that this limit doesn't really exist. So the origin, it is like now when we have this function is situated at the origin. If this limit doesn't exist, we have to approach the origin from either side. Let me say now we want to approach the origin from the x-axis, from this side. When we approach it from the x-axis, we can say that the value of y is 0. So we are going to use 2 cases, up to 3 cases to prove this. So let us now approach the limit from the x-axis. As we can see on the x-axis, it means you are going to make y to be 0. So this is our limit. The limit on the x-axis when we approach 0, so we have x, it means now we make y to be 0 plus 0, all this over x squared plus 0. Then now it means we're going to have the limit as x approaches 0. X times 0 is just 0. So this is now 0 over x cubed. And then we're at this particular point. It means now we can do the direct substitution. 0 over x cubed. This is just a 0. This is a 0. Then let us also try to approach the origin from the y-axis from this side. If we approach the origin from the y-axis, it means we are going to set x to be equals to 0. So from our limit, and then y approaches 0 from the y-axis, this is our limit. Then we set x to be 0. So where there is x, we are going to plug in 0. So it means now we have 0 y plus y cube, all this is over. Then we set x to be 0. This is 0 plus y squared. So this is the same as when we have the limit of y approaches 0. 0 times y, this is just a 0. And now we will just have y cube, all this over y squared. Then y cube over y squared can be simplified further. The limit as y approaches 0, this is just a y. Then now we can do the direct substitution. When there's y, you can plug in 0. It means now the answer is 0. So when we check these two are the same, it does not mean that the limit exists. Remember, for the limit to exist, when you approach the origin from either side, you must get the same value. Let us now try to approach the limit from this side. This is the line y equals to x. Y equals to x. Let's see if the limit will exist. So we will now have the limit. This is our limit xy. So either we make x to be y or y to be x, but at this point let us make y to be x. So it means if we make y to be x, we'll have x times x, x times x plus x cubed. All this is over x squared plus x squared. Then x will have to approach 0. If you make x to be y, it means now at this point you have to make y to approach 0. Then you solve further. It means now you'll have the limit as x approaches 0. X times x is x squared plus x cubed over 2x squared. Then solving further, it means you are going to have the limit as x approaches 0. Between the two, we have a common factor. We can take x squared as a common factor. So if x squared is taken out as a common factor, inside we'll have 1 plus x. All this is over 2x squared. Then now we can say that x squared will cancel x squared. It means now we'll have the limit as x approaches 0 of 1 plus x. And then at this point, you can do the direct substitution. So if we plug in x, we plug in 0 where there is x, we'll have 1 plus 0, and 1 plus 0 is just a 1. So, okay, there's a mistake. I left the 2, must have over 2 like this. Must have this over 2, it counts. So also here we must have over 2. Yeah, it means now our limit gives us half. So as a conclusion, we can say that 1 over 2 is not the same as 0. It means now this limit does not exist. the limit does not exist. This is all what you have to do if you want to show whether limits exist or not. You approach the origin or the point given from either side. If it happens that the values are not the same, it means the limit does not exist. Then we can look for one more problem to show this. Let me say now we have the limit of x, y, 0 and 0. Then we have x squared minus y squared over x squared plus y squared. Everything is raised to the power 2. It means, so remember when we want to solve these limits, we said that we have to first do the direct substitution. This limit doesn't exist. All we have to do is to prove. So when we try direct substitution, we will have 0 over 0, and 0 over 0 is undefined. Therefore, we are going to prove that this limit really doesn't exist. So it means we're going to approach the origin from the x-axis. Then on the x-axis, we'll say that we are going to make y to be 0. Then our limit from the x-axis, x will approach 0 because 0 is the origin. Then this is our limit. We will have x squared minus 0 over x squared plus 0, everything raised to the power 2. Then this is the same as the limit x approaches 0 of x squared over x squared, everything is raised to the power 2. Then x squared of x squared is the same as 1. It means now you'll have the limit of x approaches 0 of 1. 1 squared is just a 1. And then this is just a 1. Then let us approach the origin from the y-axis. So on the y-axis, we make x to be 0. So we will have the limit of y approaches 0. X is now a 0. It means we'll have 0 minus y squared over 0 plus y squared to the power 2 like this. Then you can proceed by saying the limit as y approaches 0. 0 minus y squared is just minus y squared. It means we'll have minus y squared over y squared. Then you raise everything to the power 2. Then now you'll have the limit as y approaches 0. Minus y squared over y squared. This is minus 1. Minus 1 to the power 2 is just a 1. And then this will give us 1. And then it does not mean that the limit will exist. Remember, we were told that this limit doesn't exist. All we have to do is to prove. Let us also approach the origin from the line y equal x. So from the line y equals to x, we will have our limit of x squared. Then we will make x to be y or y to be x. Let us now make we can make y to be x. Yeah, we make y to be x. So if we make y to be x, we'll have x squared minus x squared. All this is over x squared plus y squared. Then you raise everything to the power 2. This must be x squared if we make y to be x. Therefore x must approach 0 like this. Then when you write this point, you can add the like terms where possible. This is the same as the limit as x approaches 0. x squared minus x squared, this is 0 over x squared plus x squared, this is 2x squared, and the final answer here that we'll get is a 0. As you can see that this line is not the same as this line, then we can conclude by saying that the limit does not exist. So we have shown. This was all for this video, and thanks you for watching this video.